Welcome, everyone. Today is Saturday, December 20th. This is week 7, day 4 of India Evening and Weekend Platoon. Today, we're going to cover SQL schemas. But before we jump into that, I just wanted to do a quick recap on Thursday's lesson. I know we didn't get a lot of time on Thursday to work through the assignment school, so I kind of wanted to start the class today with a little bit of time to work on school so we could have someone kind of walk through their solution later. But before we do that, I wanted to just show you, not show you, just go over what we covered a little bit on Thursday and the assignment that you were given. Alrighty. Can everyone see my screen?
Yep.
All right. You guys recognize this, right? CARS database from Thursday's lesson, yes?
hmm
Okay. We are interacting with the Postgres database inside of what?
The Docker container.
Inside the Docker container. Can you interact with the Postgres database outside of a Docker container? Like, do you need a Docker container?
You don't need it.
Yeah, that's really good. You don't need it. It's a nice to have. You could create a database inside a container. You could quote unquote Dockerize it, but you don't have to. All right, so this is kind of this is not kind of, this is the database that we used for a lesson on Thursday, right? And we ran all of these commands. And something was a little bit confusing for everyone that I actually didn't catch until I actually sat down and I looked at it. When you go, and this is the lesson for Thursday, right? Breaking down big queries and how kind of how you go about it, right? And we pseudo-coded it in class. Awesome. And then we got to the assignment, right? Which was SQL School. I believe it's here, SQL School. And when you go through this assignment, and I think we barely got started on it on Thursday, and people didn't really have um, enough time to go through it. So we're going to go through it a little bit today. But what do you notice when you look just through this assignment? What do you notice?
It's not a pre-built database.
Yeah, it's not a pre-built database, right? And it's not Dockerized. Is that right?
Yeah.
And remember at the end of Thursday's lesson, I said, hey, when you looked at CARS database, right? You had all of these commands. And I said, hey, these are just individual commands. You could create, you can run every single one of these commands individually, right? So the way that this is structured, it was kind of structured kind of awkwardly. They should have taught you how to do it manually before giving you a file that uploads that database with all the data. Because this effectively it's an abstraction of what you're actually doing. So this lesson should have came first. I'm going to stop right there. Does that make sense? Yes? Okay, and that's what was confusing kind of a lot of people. It confused me towards the end of the class on Thursday because I hadn't really fully looked at the lesson. But when you look at this, right, they just want you to walk through all the steps without the Docker container, right? Without a high speed init SQL file that you can just execute, right? So you start going through the steps a little bit more manually, right? Even here, it's creating the schema with the schema file, right? But these are just individual commands, right? And then it's asking you to test your schema. right? And I think this is part of this is kind of where people were getting stuck. They didn't understand how this worked, right? All right. Does a bash shell inside a Docker container work the same as a bash shell on your computer?
Yeah.
Yeah, it's the same type of environment. Now, if there's different things in those environments, right, it's possible that it exists in a bash shell on your computer and it doesn't exist in a bash shell inside a Docker container. Let's say I create a Docker container with nothing in it and I go into its terminal, right? And I say, hey, open a bash shell in this Docker container with nothing in it. What files are
Yes.
going to be what files are going to be in there?
It's going to be the files from whatever OS was put in there. So like Alpine or Python Slim, whatever.
Yeah, but outside of that,
Anything you copied into there, but that's it.
yeah, the answer is really nothing, right? Right? If you created a Docker container with a specific OS, it's going to have those files. Those operate that you're not going to mess with, right? But outside of that, it's not going to have anything in there. I hope that that makes a little bit more sense. Okay, any questions about school assignment? I kind of want to take a little bit of time to give you uh, so we can go through this. Has anyone finished this assignment by chance? It's okay if you haven't. We barely had any time on Thursday. All right, no worries. Okay. I want to give at least 30 minutes to kind of work through this assignment and maybe someone can share. However, if you finish early, what I would like you to do is take the school assignment if you finish early. Take the school assignment, this assignment. You could run all of this inside a Docker container. What's the only thing you would need to do?
Build a Docker container.
Build the Docker container with what specifically?
Postgres.
With Postgres, and you can even copy these two files in there. So then you can seed everything, right? Can a Docker container execute files that you copied into it?
Yes.
There you go. All righty. That's it. Any big questions about the specific assignment, SQL School, before I cut you loose again? I want to give you a little bit of time to work on it.
Just the beginning part, right?
I know I want you to work through all of it. This is not very long. I'll give you a brief overview of what you're just going to do, right? Uh, you're going to practice this. This kind of reminds you of what? I think I mentioned it maybe on Tuesday.
CRUD.
CRUD. Yeah. Inserting is kind of like creating, updating is updating, deleting is deleting. Well, inserting is kind of like creating, right? Updating is updating, deleting is deleting. All right. So here you just create a database, right? Here you go you go into the database, right? Create your schema, right? When you create your schema, you're just creating the tables that are going to exist and their relationships. And that's the main thing we're going to cover today inside your database, right? Here you have these nice little SQL files that do it for you, right? If I go in here, right? If I run this, if I execute this file all together, it's going to create how many tables?
Table.
How many tables is it going to create?
One.
Look at it again.
Four.
Yeah,
Yeah.
4. I'm not trying to trick you guys.
Oh, I thought with the semicolons just
That's
like would
1,
terminate. Okay.
2, 3, 4, right? And then it's going to here, it's just going to seed a bunch of data. So here you go. They give you a little bit less data here, right? But actually, I wanted you to make one change to this, right? Instead of running the files and seeding the entire files, you could insert these commands one by one, right? Try that first, and then you can run the files. And then we'll come back together, and hopefully we'll have someone share. All righty, guys. I know it's early. I'm going to pause it right there. All right, guys, we're back. How did that go? That lesson is just a practice lesson. All right, we're not collecting anything. You're doing everything in your terminal. How did it go?
That was terrible.
Was it really?
Um, I don't know. I don't know how everyone else did. I ran into a couple of issues with some errors about. Oh, I saved them. So I tried to be slick whenever I was building my schema, I guess, and I decided that a grade should be an integer because it's generally a, two-digit number. Um, I misread it, and apparently that's the grade that you're getting in the class, so it should have been a string. And when I finally figured it out, because it's pretty clear error, it says invalid input syntax for type integer B. And I kept changing the schema and it just wouldn't take. And I finally wiped out the whole database, remade the database and had it set as a string and it populated. So I got some of my data in there. And then I noticed there was a line 2 for addresses in the one of the either the assignment or the schema itself. But I added that in, and so I'm getting some failures about line 2 not being violating a not null constraint. So it was a lot of good practice in working through the error codes in Postgres.
Violating a not null constraint means that specific column value is a what? Or that specific row value in that column is what?
Required.
Yeah, can't be null. But good. Slightly abstract. Do you ever fill out a form and it requires your password to be, 15 characters and have a capital letter? But they're forcing that requirement to be what it is, and it won't let you move on to the application or the form if you don't do it. Make sense? It stops you from breaking their application. Right? So a lot of good practice. That's all it was intended to be. Good. Anyone else?
If
All right.
I'm actually updating a table, let's say I messed up, so I have to drop the table again and redo it again.
That's the easiest way, yeah.
Okay, good to go. Thank you. What's the hardest way?
I mean, you could go in there and manually adjust it, but when you get into building applications and schemas later on, when you start building the full stack application with Django on the back end connected to a database, it's just easier to drop the table. So if you're dropping it right now, that's fine. Like just find something that you know how to do and just do it that way until you figure out a better way to do it. Does that make sense?
Yeah, it's easier for me that way.
Yeah.
Definitely.
So right now you may be doing things that are not that efficient. That's okay. What's really important that you can get the job done,
Okay.
right? Super important. Which actually leads me to my first talking point. I saw Jose do this, which was really good. He was just copying and pasting from a previous lesson in order to redo the current assignment in a Docker container. That's really good. Look, feel free to use all the lessons that we have covered and copy and paste from those files and edit. That's not cheating or anything. That's what you should be doing, right? That tells me that you can go into other lessons, pull the information, you know what it does, right? And piece together this new answer for this new assignment. Does everyone understand that? That's what you should be doing above everything else. Copying from any old lessons. That was really good, Jose. And everyone else should be doing that if you're not. Or even just looking at it, right? Having it to the side on a side monitor and then typing it out word for word. Okay, I know that this does this, and then just editing it. So I saw that. That's really good. The biggest challenge that I saw right now was a couple of you. This actually applies to, I think, a handful of you are having issues with your terminal, right? Especially if you're on Windows, you're having to type sudo to get all the commands to work. That's because the user actually, Dan, were you able to get that figured out?
Yeah, I figured it out and had the school DB made. I was
Okay,
able to get that.
can you just tell everyone how you fixed it? Because I think a couple of people are having your problem.
Let me post it in chat.
Yeah, post it in chat and just tell everyone what you did as well.
I had to add I'm using Linux Mint. It's basically Ubuntu with a different front end or GUI. Added my user account to the Postgres group and then had to log out or reboot. And then ran the sudo su-postgres to get into the, run the Postgres. I think that's where I was having problems. And then ran PSQL, created a user, my username with password, but that it said it had already existed, so it didn't do anything. And then create database school, and then I quit out of that, and then I PSQL'd into the school database and /L plus to verify that the school database existed. And that's about all I had to do. I haven't got to inserting or editing any of the tables yet, or the schema.
No worries, Dan. Thank you for that. So that's a permission issue within your terminal, right? So you need to, there's two ways to go about it. You can fix it, or you can just always do sudo, sudo, and understand that in your terminal, that's how it works. You're the administrator though. You should be running under admin for right now. It shouldn't be like sometimes I saw a couple errors of like, hey, you can't create this table because you don't have permissions. Switch user or create a user that has all of those permissions. Because writing in typing in sudo and all that stuff and identifying the user is kind of a pain in the ass. If you don't know what I'm talking about, that's good. It means you're not having that problem. If you know what I'm talking about, then I would address it or at least figure out a workaround. Does everyone understand that at the very least? All right, what are the two tenets of Linux?
Where am I and who am I?
Yeah, a lot of you guys are having a who am I problem. You don't understand who you are in your terminal, right? Therefore, you're running into a lot of permissions issues. I personally would just run an admin right now because let's just assume that you know what you're doing at the moment. All righty. So we're going to do a lesson right meow. And today's lesson is SQL schema. Can everyone see my screen? Yes?
Yep.
All right. When people think of databases, before people become devs or people are not devs and they just think of a database, they typically think of If you ask them to describe it, they would typically think of this right here. Right? They would think of like, rows and columns and Bobby Joe and Sally and a bunch of information with these users, right? All together, right? What's wrong with this database design here?
With some missing fields.
Yeah, there's some missing fields. What else?
The name and address not broken down like granular enough.
Yeah, maybe that, right? Maybe this is not broken down enough, right? This is Bob Jones, right? And it's combining a lot of what?
Like data types, like you have your orders as well as the birthday and age in there. Like those two shouldn't really have anything to do with each other.
Yeah, and you kind of already know that because we've already introduced tables, right? But if you look at this database, right, how a normal non-dev person would look at it, they would kind of think of it this way, right? Hey, just give me a database that has all the information that I need, right? Right. And if the information is just a little bit of information, it more or less works, right? But this has a bunch of problems, especially when it scales, right? And I want you to really look at this table, right? And think of these questions, right? What would happen if Bob Jones moves to this data table? What happens if they moved? What would you have to do to this database?
Change it.
Change it to what?
His new address.
Yeah, it changes his new address. Okay, so imagine we do have just this database. Bob moves and we change this address, right? So in the database, do we delete this address and write the new address?
Yeah.
Okay. What if in your state there is a law that you have to keep people's personal information for 10 years?
Now you're a criminal.
No. So you can't delete it. If you have to keep a person's information for 10 years, right? So and they move, okay, you have to change their address, but you have to keep your old address, right? At least for a minimum of 10 years. So how do you do that in this table?
Yeah,
Another column.
another column named previous address.
Okay, what if you have a person that has moved every year for 30 years and you have a person that's never moved in 30 years? What are you going to run into?
Bunch of optional field columns.
Yeah. So you start getting a really unwieldy database, right? Where a lot of the columns and rows, depending on the user, are what?
Unnecessary.
Unnecessary and empty. Is that taking up a lot of resources? So you kind of get what I'm getting to now? It becomes really unwieldy and really hard to manage. And ultimately, the only thing that drives the bus in this world, it becomes expensive, right? So you wouldn't ever do it that way, right? Let's look at the second one. Or what if Sally changed her name, right? Sally Smith gets married. She is my last name's Aguilar. She is Sally Aguilar now. What do you do with that name?
So I don't, do databases do versioning?
Yes, but I don't want to get into it right now because that's a whole different ball of
Okay.
wax,
Gotcha.
right? What happened if Sally Smith gets married to Guillermo Aguilar and she changes her name? How would you update this database?
You'd have to append.
Alter column.
Yeah, you have to add another column or something, right? Says, hey, like maiden name or married name or whatever the case may be, right? But then if Sally Smith is now Sally Aguilar and this has a different column called, right, married name or maiden name, right? Would that column exist for other people that never got married as well? Okay. This is just a thinking exercise, guys. I just want you to think about this, right? How unwieldy this database would become. And that's the only thing that this is meant to emphasize. This kind of gives you a couple more questions to think about. What if someone ordered more than one kind of item, right? Here, you lump it all together. You tend to have personal information like first name, last name, address, age, and birthday, right? And then you have this database kind of would be for what kind of application you think, or what kind of store?
Yeah, like an online shopping store.
Yeah, like an online shopping store. It seems to have a lot of personal information, and then you're ordering something. I don't know what it is, but you're ordering something. Okay, cool. So the pros of this database, right, is you have everything in one place, right? The bad thing about it is it won't scale, and updating data likely will be very, very dangerous. We can break down the issues with one big table approach into two basic categories, repetition and integrity. These are the two really important database ideas. Someone asked a question about whether there was versioning in databases. That's another thing that we won't get into, but that's another thing. Autonomy is another one. There's a couple more things, but these are the starting points. All right, repetition is already familiar to us in general programming. We really only need to store Sally Smith's address once. We don't need to make a new copy of the information every time she places an order. Let's look at our big table, right? If Sally Smith, right, look at her order item. It's a lamp, right? If Sally Smith orders a desk in this type of database, you would have to do what?
Be another row entry, right?
Yeah, it'd be another row entry, and then I'd have a desk. But what information would be duplicated here?
All the personal information.
Yeah, all the personal information, which is ultimately just going to take space and cost money. And so that's really an efficient way to do that, right? So that wouldn't work. And another thing here is notice how they have a column of birthday and age, right? But you actually only need the birthday, right? And you can derive someone's age, right? So this age column is effectively what?
Repetitive.
Yeah, repetitive or pointless, right? All right, so repetition. We gave the example of Sally Smith ordering a bunch of packages, right? And having to duplicate those rows. There's no need for that, right? So keep that in mind. We don't want to do that. What's the drive principle in software engineering?
Don't repeat yourself.
And you don't repeat yourself because it makes code hard to maintain, but ultimately you don't repeat yourself because it takes up too many what?
Resources.
Resources, yes. All right. So repetition, try to avoid repetition at all costs. That's just a general software engineering principle. For the two main reasons, it's just too hard to maintain and it's ultimately too expensive. So integrity. Integrity has to do with how reliable your data is when things change. What if Sally Smith types her address incorrectly one time, leaving you with two different versions of her address? What if she moves? What would you need to update her address to in other records, right? So these are some of the kind of the examples that I was giving. I gave the Sally getting married example, but it's the same, right? What happens if personal information changes here, right? You would have to alter a big database or create another row or create another column, right? Yes? Look at this. If Sally Smith, according to this table, ordered a desk, I would have an extra row. But if Sally Smith got married to Guillermo Aguilar, and I'd have to have a maiden name and a married name, now I added a column. And I'm just giving you two little examples, right? What if this database is being updated 100 times a second? How big does it get? Make sense? And I know what you're thinking, and humans are not particularly good at thinking in big numbers, but 100,000 database reads or updates a second is actually not that much. Not that much for a really big application. Think of any major application that pops to mind right now. It's doing way more than that. It's probably doing in the millions. Alrighty. So keep in mind integrity and repetition. So entities. What if instead of SQL, you had to take this table and turn it into Python classes? You might start with something like this: customer, order, and item, right? What kind of attributes would these entities have? And these are pretty self-explanatory, right? A customer would have some kind of ID, name, address, age, birthday. Yes? And then order would have something like item, quantity, customer. Yes? And then item would have something like number, description, and cost. What are we making the transition to here? What's happening here? We're talking about databases, and all of a sudden we're talking about what?
Classes.
Classes, but why? What's going to happen here?
They're similar in their structure.
They're similar in their structure, and ultimately you are going to map your Python classes onto your database. Remember a while ago we wrote the class animal shelter? You guys remember that? And an animal shelter took in pets, right? Took in animals. And how many different kind of animals could a pet shelter have? A bunch, right? Those are all just classes that ultimately map to a database. Yes? Start kind of thinking about that. That's exactly what's going to happen. So when you write an application, right? We did what was your assessment? I can't remember. Was it video store?
Blockbuster.
All right, Blockbuster. Think of Blockbuster, right? And how that would map to a database, right? Let's go through it right now. You have Blockbuster, right? Let's just look at the database piece of Blockbuster. What kind of tables does the application Blockbuster have? There is a Blockbuster database. And in the Blockbuster database, what are the tables? Just run through it.
Customers and videos that you have.
Customers, videos. What else? Maybe this wasn't included in your specific assignment, but think about Blockbuster when it really existed, or just any rental movie store. It had customers, it had videos. Is that what you guys said? I can't remember. Customers, videos.
Yeah, and then their payment options.
Payment options for sure. Right? Those are the three big ones, right? But there's also, what else can you think of? Who works at Blockbuster?
Employees.
Employees. Don't you think that if Guillermo rented a video to Nicholas, his friend, and he didn't charge him for it, they wouldn't be able to track that down? Who scanned it? Whose employee ID? That's also a table, right? Yes? You see how that works? I hope that makes sense. Like in my head, that all that makes sense, right? Right. So when you think of like technology and Big Brother, right? In the olden days, right? Someone had to log into that computer, right? With some kind of customer ID or a badge swipe or something. And everything that person did was logged on that computer. To the second, right? To the second. Keep that in mind. All right, so just a simple Blockbuster, right, would map to a database with users, payment methods, videos, right? Or maybe videos would be just a subcategory of like media, right? Because maybe they didn't have just back in the day they had like VHSs and DVDs, right? Sometimes, and then they came out with Blu-ray. Those are three different categories, right? They would all be subclasses of like media or something, right? And all that would map to the database, right? Because somewhere in there, it said this person rented this type of media, right? Keep that in mind. We're doing the exact same thing here. This is like an online store example, right? We have customers, we have order, we have item, we have address. And this address is whose address?
All the customers.
Yeah, all the customers' address. Let's not get too big here, right? But for Blockbuster chain, right, it would be a different class for the Blockbusters themselves, right? Because at one point, I think there was several hundred, maybe thousand across America. Yes? All right. So here we go. This app, this online store would have customer class and order class and item class, but we could break this down even further. What about address? Arguably, an address is actually a very complex object. We could pull it down as its own separate entity, and an address could be number, street, city, state, right? What do you think is going to happen here? If we broke down address here in the customer, this is just like a little, let's look at it. Customer up here. Notice customer. What is address here? Given this context. It's nothing, right? I didn't give it anything. So conceptually, this could have been just a long string, right? But it wouldn't be just a string because in the real world, addresses are complex. So an address would have to have all this. Yes? All right. So you can kind of see what's happening here, right? What's this ultimately, before I scroll down, and obviously you can scroll down on your own and you can see kind of where I'm getting at here, right? But ultimately, this class, this customer class will reference what?
Other classes.
Yeah, other classes. And in this case, it's going to reference which object?
The address class.
Yep, the address object, right? Or the address class. And you can do this because everything is a what? Object, right? Can a function take another function as a parameter?
Yes.
Can a class take another class as an attribute? Of course it can. Why?
Inheritance?
No, I'm just going for the simple answer, right? That everything's an object, right? We don't want to go into the nitty gritty of inheritance or polymorphism or anything at the moment, right? But just know that any class can reference any other class. Any function can take any other function as a parameter, right? Ultimately, everything in Python, it's an object-oriented language, right? Everything's an object. You can pass it, you can reference it. Yes? Okay, cool. So we could keep going and continue extracting entities and making refinements, but this is fine for right now. But let's do this just as an exercise, right? So this is kind of a tougher question, right? We gave you the easy one here, right? We wrote these three classes. Grant you, we haven't written any of their attributes here. Here we give them specific attributes, right? If I look at this, I gave you address right here. That could be another class. Look in here. This is kind of a tough one. What else could be a standalone class here? Well, actually, let me start with a slightly easier question. Look at these three classes. Let's start with an easier one. Which of these attributes is redundant? One of these attributes are just not needed at all. We talked
Just
about it
age and
earlier.
birthday.
Yeah, the age we don't need. You can derive it from the birthday, right? And actually, setting this age here is actually really bad. Can anyone tell me why? This is kind of a big brain question here, right? Setting the age here would actually not be the optimal way to do it. Why?
Because it changes every year.
Yeah, it changes every year. Are you going to go into your database and update everyone's age? What if you have 10 million users? Changes every year. Yet here, if you have the birthday, you subtract from current day. There you go. Gives you the birthday to the months and the days if you wanted it, to the seconds even. I don't know if you've noticed, but if you check your birth certificate, it tells you what time you were born. I don't know if anyone knows that. Right? All right. So yeah, this one, you would never actually use this, right? This is, I don't know why they included this, right? But it's actually good for me though, because I used this as a kind of a learning moment. You don't need this. And actually you would never use it. You would only need this. All right. So if I looked at these three, then back to the tough question, can you think of any that could be their own standalone class?
Birthday itself.
Why do you say that?
Because then you can, if you want to pull information based on people born in a specific month, and
If you wanted to, yeah, if you wanted to do that, you could. You could. This can go kind of as deep as you need it to go. There's no right answer to the question I was necessarily asking you. It depends on what your application wants to do. But for this specific application, this address actually becomes really important, right? Because they're doing what? Why is address really important to this kind of application?
They change.
No. What type of application is this? It doesn't specifically tell you, but it's kind of like online shopping application, right? So why is address really important to an online application?
Shipping costs.
Yeah, because they're shipping everything, right? Yes. Right. Probably if I had to guess, let's look at Amazon. Probably the thing they do better than everyone else is probably their logistics. The fact that they've built an infrastructure where they can deliver promptly and sometimes within 24 hours, pretty much anything you could possibly need, right? That does not happen without great logistical structure underneath, right? Cool. All right, so as address, we could keep going like I was saying, but we're not going to, right? Instead of defining these entities in Python classes, let's see what they would look like in SQL. Unlike Python, SQL wants you to tell it what type of data a given column will be. Postgres has a bunch of types to choose from, but here we're going to keep it super simple. And this is what it would look like in SQL. Create a table address, number int, street varchar. Varchar is just a string. City varchar, state varchar. If I look at this table, just based on what you know so far, how many of these are optional in my table?
all of them.
Yeah, all of them. There's no not null anywhere. But yeah, I was just checking if you understood what that meant. All right, all of them. Cool. If you wanted them not to be optional, you could put not null, right? So then when you, let's say you try to create this table and you try to insert into this table and you had not null in all of them, it wouldn't let you insert, right? Without every single one of the attributes being populated, which sometimes you need it, sometimes you don't, right? When you're filling out a personal form, name, last name, phone number, email. What's one that's always optional? As far as your name is concerned, what's one that's always optional?
Middle name?
Yeah, middle name. Why?
Because they're also optional.
Exactly. I don't have a middle name. My sister does have a middle name. My brother doesn't, and then my little sister does. The girls have them, the guys don't. All right, yeah, they're optional. Guys, some people don't have them. I can't write something I don't have, right? All right, so don't overthink it. Just kind of yeah. I don't have anything more to say that. So here we have a customer, right? A customer table, right? Serial primary ID, right? Varchar, address. It puts it in quotation marks for a second here. Age, birthday, and it tells you what kind of value you're going to get into that database, right? I'll get into that later. Here creates the order table, and it creates a table. The order and then the item. So these are your 4 tables, and the 4 tables are just pulled from where?
From the code.
Yeah, from the classes, from the Python classes, right? Ultimately, all of your Python classes will be mapped to your database. What are the fields that I'm not sure about? What about customer address? It's not just a primitive value like a string, which is a varchar in SQL, but reference to another table. And what this is getting at is kind of what we discussed up here, right? Here, address is really going to be a reference to another class, right? And it's the same thing in SQL. You're going to see it right here. Customers.
Oh, go ahead. I'm sorry.
No, go ahead, Brian.
I was just wondering if is this ORM?
No, we're not getting to that yet, but it's walking the line. We're walking towards that.
Because I mean, can you actually run Python code and get this, can you make a schema in the code aside from ORM and Django and make tables?
No, you use our ORM for that.
Okay. This is just okay.
Yeah.
Okay, gotcha.
We haven't got into that yet, but that's kind of where we're walking the line, right? Where you understand Python classes and you understand SQL. What's missing? How do you map your Python classes onto your database, right? Yes? All right. So remember I told you you're not going to write raw SQL queries? This is where this comes in, right? Ultimately, you just write Python code, right? That creates a schema that adds the information in the database, that pulls the information from the database, right? As you already saw practicing this, writing those SQL queries is really what?
Tedious.
Yeah, it's really tedious and error prone, if you haven't noticed, right? So you wouldn't normally ever do that. And we don't, but it's important that you understand what's happening under the hood, right? So this is kind of where we were going at here with the customer table. Notice that up here, right? We left the address blank here outside of it being a varchar because ultimately, right, it ends up not being a varchar. It just ends up being a reference to another class, or in this case, table. Does everyone understand that? So what you learned in Python classes conceptually applies to SQL here because all those classes are mapped to a database. Does everyone understand that? That's probably the most important thing you have to understand right now, right? Everything that you write in Python will be mapped to your database.
Yep. Well, I've
All
actually done it, so I understand it.
Yep. All right. So this, I just covered exactly what I just said, right? So the challenge is to design Craigslist. But you're going to notice, right? Let's go through this. There is not a lot of information here. Let's look at what you are going to clone. And I'll actually go ahead and do this. Feel free to follow along.
Are we going to work on this again? Are we going to have time to do this again, or are we going to go to another one?
Do what again?
Work on the Craigslist thing, or are we going to do something else?
No, we're about to work on the Craigslist thing.
Okay. I mean, like for the rest of, because we have like 4 hours left or something.
I promise no one will finish Craigslist. Is that what you're worried about?
I'm not worried at all. I'm
Thank you
just,
for volunteering to present at the end of class, Brian.
oh, okay. No, I'm just curious. Like, are
No, no,
we?
no, 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 no. You volunteered. I got you. Okay. We're gonna clone this, and I don't know why that clone wasn't working. I'm just messing with you, Brian, but you're more than welcome to volunteer
Julie's
though.
laughing at me.
All right, here we go. This is exactly what you're going to do. I just went. Yeah, why is this not working? All right, I just went to the only challenge for today. We're going to design Craigslist. I go here. This is all you get, right? It says you're going to design the schema for Craigslist. Keep it as simple as possible. If you want to go all in, do a second pass. You probably want to have a what? User add and category tables. Once you have the schema design, you can use all these tools. I personally don't like them, but if you're comfortable with them, feel free to use it. And it's teaching you to definitely pull information from CAR's database, right? So it's asking you just to create this Craigslist schema, right? But let's look, if you clone this, this is what you're going to end up with, right?
Blank screen.
Docker is empty. In its SQL, it gives you some pseudocode, I guess. Create a database, connect to the database, create the tables, insert data. And then it has a README that just literally has very little. All right. So if I told you, right, and that's why we're going to do this together, because I think this is kind of a big jump here. If I told you this is the CARS database we're going to pull from, right? If I told you, hey, I want you to create the Craigslist schema, or I want you to create a Craigslist database, right? So here it is. We're all going to do this together. Go ahead and clone it. I just created a folder called it Craigs, and then I'm going to CD into Craigslist schema. Okay, this is where everyone should be at right now. And if you were told, hey, design a Craigslist database, how do we do it? How do we want to tackle this first?
Make a diagram, I guess. That's what the that's
Yeah,
what the reading said. Do make a list, like a block, a classes list or something like that.
All right, a list and a diagram are two completely different things.
Well,
How do you want to tackle this?
I mean, the reading said do like a uh I can't think of the name of it. But you know, those diagrams, it's got the squares on it and it's got the lines
Yeah,
between all
it says,
that.
hey, once you have your schema designed, right, you can visualize it using one of these tools. You can,
Yeah.
right? You can. I'm not going to do that. I'm not particularly good with the design tools personally, so I don't really use them. But let's say you were straight going into designing it, right? This is where, when I cut you loose, and we're going to take a break, and then you're going to jump back into this, and I'll give you partners here in a second. This is where you start off. How would you like to start? There's a
So,
couple different
are they
approaches
trying
you
to
could
do-
take here.
Oh no, I was gonna say I was trying to build like muscle memory off of this. So
Yep.
it was first I would clone the thing. We did that. Next, I
Yes.
would try to I need to get Docker to make sure it's there. So
I
that
need
way
to
we can
get
create-
Docker. What does that mean?
I need to just make sure that it's installed and running.
Okay, my Docker's up.
Okay.
I don't have anything
Um,
running, but my Docker is up. Yes?
Okay.
Mhm.
Yep.
All right. Now what?
All right.
And
So
guys,
now
everyone pay attention to what's happening here because you're going to get stuck here, I promise. Right. All right, Jose, keep going. You're saying all the right things, right?
okay. So now I need to create my Docker image.
How are you going to do that?
Let me pull up. I always have to go back to this one, but basically, it is. Let me just pull it up here. So I'll do Docker build -t, and then we'll call this one.
You can't build it because what is wrong right now?
Oh, that's right. Well, we gotta create we gotta make sure the init is straight, but we also have to make sure the Docker file is I guess the syntax is in there. So like on there for the Docker file, if I take a look at what I have on the other one, on that for the
This
Docker file, you would have to go from the first line would have to be from Postgres colon 15. So yeah, basically that there.
This?
Yes, sir.
Okay. I've populated my Docker file that is only going to copy this file into my container when it starts. Great first step. Now I'm going to go into init here, and there's nothing here. So I could start the Docker container, but if I start my Docker container right now and if I build my image and I start my Docker container, what's going to be in there?
nothing.
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 And it'll keep
Nothing.
shutting down
There's
because that's what
nothing.
I'm running into.
Yeah, there's going to be nothing in there. Okay, so what's the first thing that I want to do here then? When my Docker container starts, I want to create what?
A table.
I want to create a what first? Not a table. You can't create a table unless you have a what?
This is number
Schema.
one.
Database.
Database. Database. Whoa, 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 whoa. So all this conversation is actually really good. We needed the database first, right? And then we can talk about the tables in the schema, right? All right. So I wish I knew how to create a database. Where would I go?
You go
Google
to the,
I could Google that, or I could go where?
I mean, well, yeah, to the card database and just,
Yeah, go in here. You will have a version of it.
hmm
All right, cool.
Copy paste.
I'm going to take this, create database. It's not cars. I'm going to call it Craigslist. Perfect. Now I'm going to create a Craigslist database. Awesome, 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 awesome. That looks right. All right, now what?
Connect it. I guess
All
you go
right,
back
I'm
to
going to
the phone.
connect.
Yeah.
I go in here. It says connect. Cool. I am going to connect to it. Not cars, Craig's. I don't even know if that's how you spell it. Craigslist. Is that right? Is there a colon there? No, there's no colon there. Cool. Awesome. All right. So I have code right here that's going to create this database called Craigslist. Actually, does this even use? I'm just going to do no underscores. Less chance of mistakes. All right, cool.
It's pretty much isn't this pretty much like a script for SQL?
Yes, it
So
is.
you
That's
can
exactly what it is.
so I mean you could just I mean I think SQL likes semicolons after the lines.
I am going to follow this, and I'm not going to get into the nitty gritty. I know that this works, right?
Yeah, yeah.
I'm not going to stray away from that. That's what I'm teaching you to do.
Okay.
Right now, you're in the beginning stages. I really don't want you to write anything from scratch unless you're super confident that you can get it right. All right. So here,
I think the connect, yeah, no, I was just commenting. I think the connect cars is more of a command, a bash command, and so you wouldn't
Oh,
need a colon.
yeah, I think you're right. It's a bash. Maybe. No, it's SQL because it's bash doesn't use that forward slash or backslash.
so on this, what's happening is we created the database, and then if you see the backslash connect cars, now we're in the database, and now you're using the database syntax.
hmm
So that's why we're able
okay.
to do the table.
Okay. So now I'm inside the database. And what do I want to do?
You want to create tables in it. You want to
All
add.
right.
Yep.
So this is Craigslist. What's the first table that I want to create?
Customer or user.
Yeah, let's call it user,
Yeah.
right? And I'm actually just going to copy this, and I'm just going to edit it. And I'm only going to create just user. I'm going to create a table called user, and this person's going to have that. That's it. Actually,
What was the other
how about-
stuff? What was the other stuff?
it doesn't matter.
Mhm.
All right. And I'm actually gonna make it a little simpler, right? It's gonna have the primary serial key because eventually they're gonna have relationships to other tables. But for right now, I'm just gonna create this. And my table has how many columns?
3.
Has 3 columns. Cool.
Why did you take out the
Awesome.
last name? That's kind of important. Unless you just want to make it simple.
Brian, I'm trying to make it as simple as possible. I want you to
Okay.
start this first, and then you can add complexity to it. Okay, so there you go. I have just one table with 3 columns. That's it. All right, so now I'm going to insert data, but I know I have an example of inserting data, right? I have this,
A lot.
right? This is a lot. This is, how long is this?
But it uses all that data that you cut off. So,
Yeah, but it doesn't really matter. All righty. So if I go in here and I copy this, the ending of this is what? Colon? Yep. All right. I literally just copied that line, right? But this
James,
is the command. Insert into user values James, and then he has an email. He doesn't have a last name. Okay, cool. I'm just gonna give him this one.
is a horrible last name.
Yeah, sure.
J Butt.
Does this work?
Yep.
There you go. I created my Craigslist table user, and there's only currently one user in there. All right, awesome. This is actually a pretty good start. Now where do I want to go? Jose, you're doing a good job. Keep going. You're muted, bud.
My bad. All right. So now we got something to build a database with. So what we're gonna do is we're gonna build the image with the
Okay,
Docker. Go
cool.
back to the syntax. Docker build the
I'm gonna Docker build. What am I gonna build?
and Craigslist database.
Craigslist, like that.
Yeah.
This is good.
I've been doing underscore DV just as a rule of thumb for myself, only because I did that on the database. But yeah, this is good, I would imagine.
This can be anything, right?
Correct. Yeah.
All right. So I'm gonna build this. Yes,
Yes.
that looks like it built. Now what?
Now we're gonna copy the Docker run command line.
Docker run
Yep, it'll be
this.
Docker run dash f. And now what I had to do here was kind of update this stuff. So I already had one container from Cars database that's called runner. So I
Hmm.
had to go back to runner and rename it Walker. Just give it a new
Okay,
container.
but I don't have any containers running locally for me, so
Okay.
I could leave it as
So,
runner.
all right. And then take out Cars database and replace it with the Craigslist.
Craigslist. Craigslist. What did I call it? Craigslist DB? Is that what I called it?
I think so.
Okay, because that's the image that I want to use to launch my container, right?
Correct.
Okay, so if I run this, I should have a Docker container with this information. Yes?
Yeah.
Let's check. How do I check if I have the container running?
At this point, we'll do a Docker PS.
Docker PS.
Now we'll do a Docker PS dash A because it might not be running, but the image might be there.
PS-A.
So nothing. Well, let's
What happened here? You guys are all going to run into this. Like you can already kind of tell me what happened. What's the issue?
is it
There
the
is
port?
a no. This is too easy of an application for that.
Gotcha.
There is a what somewhere. What is it? Here.
Nothing makes it stay running. It just
Yeah.
opens and exits.
There's no
Mm.
comma after the last create table entry. After email,
Pre.
they take that comma out.
Wait, say that again.
When you deleted the user information, there's no comma on the last line when you create tables. I've done that before.
There's no comma here.
No, after unique, line 14.
Line 14 unique. There's no comma
Yeah.
here.
Yeah, you take that out and it should work.
Why was that left in? Can you tell everyone?
Because, well, when you deleted the last line. So,
Yeah, remember I got rid of some attributes, right? I forgot to
Yeah.
mention it. So
I did that before.
yeah, so the issue is there's a typo in my script. So what do we need to do now? If there's a typo in your script, kind of what I posted in the Slack channel, right? It's not going to build properly. All right, so I need to redo what?
You gotta rebuild the image.
Okay,
Or
Docker
save-
build.
Yeah, but do we gotta save it first? I don't know
That's
if we
saved.
saved it. Okay,
It's
cool.
saved.
Yeah, redo the build.
All right, I built it. Now what?
All right, and the next step after that was the 1 second.
Just run it, right?
Yep, just run the script.
Ran it. Docker PS.
And still not doing it up. So if it has an error, it should be able to build it. What about Docker PS-A? Maybe
Yep.
it's just not running.
Nope.
Okay, still didn't build. So if it's
I
not
could-
building,
So I can use the terminal. I can use this GUI if I look in here. What do we notice here? The image, it looks like it built properly, right?
yeah.
Right, but we can tell that the containers, right, are not running, right? You can definitely use a CLI as well, right? So there's something wrong with what?
Deleting it?
Maybe the Docker file.
But look at it. It's so simple. That's why I kind of wanted to start really simply, or in a very simple manner. I don't know if simply is the word. But yeah, this looks right though, right? It's not any different than this. What do we notice? All right, this looks right. This looks right.
Is it the name that we call the database? Possibly.
The name, Craigslist,
Yeah.
Craigslist.
Like the
You
underscore
ran the-
DB that we.
Say that again.
I said the underscore DB.
All right, go ahead, man.
All right, walk me through the command, Jose.
Okay, so it was Docker run space dash name runner rm and then dash e postgres underscore password equals password the first. Okay, so what we did was we're running a Docker image. It's going to be called runner. It's got the Postgres. So when it goes into Postgres to create the database, it's gonna have all that info with it. And then Craigslist, then we're gonna call it the database Craigslist DB. So it should be building the database.
Guillermo, can you get rid of the RM?
No, we need that.
We need that.
Right. So the issue, this all looks right, right? What's the issue? Probably.
Your database is wrong.
No, database is not wrong. This is right. It appears that it's breaking here.
I'm not
Oh,
really
yeah.
sure what the default is.
Is it because the email is set to text and not like varchar? Can
Guillermo,
text
No,
take symbols?
text can be this. That's fine.
Oh,
It doesn't have to be varchar.
Can I take a look at it, the Docker logs runner? Maybe it tells me what's wrong.
Yes, if the Docker container ran.
Okay, so it doesn't work like that. Okay.
This is an exact copy, right? The account ID.
Let's compare it to this, right? Like when we go in here, right? This looks right, right?
Yep.
Oh, so the email.
It's supposed to be right.
Why is
You have
there
to
an
designate.
MD5?
Do you have to insert into user, and then user, and then whatever the columns are before values?
Is that an issue? Do I have to
Insert
put
user,
what?
insert user,
First time?
ID,
The ID is default. Don't need that.
default ID, first name and email. I think it's
So
before. Let me look.
before values?
Yeah, I think, hold on a second. Insert into, yeah. Insert into, yep, values. Yep.
Is that the issue?
Assuming so, yes.
Okay,
I'll
let's
own
try it.
The only thing different I see here is the MD5 in front of the email.
Yeah, but
Delete the email.
I deleted that. Shouldn't need it.
Okay. Okay. Default. Account ID.
It doesn't look like the table is made either because this shouldn't have data underneath container ID image command created.
This all is failing, right? But I'm asking you to analyze these like 10 lines, right? We're just trying to figure out why this is not working. We need to be able to debug this and then we're done, right?
You have to do something with the default field.
I literally just copied this though, right? This should work.
Sure.
All right, I'm using app users. Let's look at app users here, right? Account ID, first name and email.
Maybe they're unique.
Yeah, I mean, we could delete it. I don't think that matters here. Is our image good? Yep. Copy this. What could we try? Do we have to, can we comment this out and just create the table? Would that work? There'd be no data in it, but at least I could tell if the table is created properly.
Yeah, you can just create the tables.
Okay, let's see. No, not the tables, the table. All right, Craigslist DB. Cool.
Is the Docker image not building? Is that the problem?
How would I check?
Well, you just ran a Docker PS and it's not giving you any data at all. When it says there's no name, we created, yeah, our name was runner. I don't see any name
No.
runner.
That Docker container is named runner, but I can delete everything if you want.
Yeah.
Thank you.
builds. We can delete everything. Not an issue. All right, we're gonna start fresh right here. And I'll see if I can I'll show you something on the GUI real quick. All right. So this is not doing anything. It's not inserting anything. I'm literally just
Making tables.
I'm not making tables. I'm making a table.
Yeah, of course. Yes.
All
A
right.
table. Exactly one table.
Yes. Docker build, Craigslist DB. You saw my Docker. There's nothing there. Cool. Docker run. Docker PS. Let me go check my Docker. Right. This is the build.
I thought you named it runner.
Can you go to images?
Images. Yep.
Click on it, or yeah, right there. And then hit run,
Run.
and then run again. Database is uninitialized.
Initialized and user password is not specified.
So
I saw
if you
password.
just if you comment out everything up to the connect line, it does work.
This.
Yeah.
Let's try it. Thank you, Scott, Logan. Guys, you guys can use this to debug. Is there a way to hit the logs for the Docker containers? There is, look it up. But yes, you can use a GUI to debug. So let's look, build it. Docker run. Docker PS.
There we go.
There's my database. There's my database. All right. So what was the issue?
I guess you need to create the database before you start creating tables.
But we do create the database here.
Yeah.
All right, let's check if that database is in there. How about that? Yeah? Yes?
Yep.
All right. What's the command? I want to go into that Docker container to make sure
It's,
that,
/DT.
no, I want to go into the Docker container.
Docker
Oh,
exec.
you gotta get into Docker. Yeah, I forgot what the thing was. Then
All right.
/DT after that.
All right. So here I'm going to exec into the Docker container. Right. Now I want to do what?
You want to go into the Postgres.
All right.
Go
So
into
what's the command?
It'd be PSQL-H localhost -P
I'm trying to go into what?
into the database.
What's the command?
It's a PSQL space -H space localhost.
Do I have that
space-
command anywhere?
Yeah, it's in the cars database, but I can flash it to you.
Here I can go cars database. It's
Just that right there from the
this.
image, or yep, that one right there, and then
But not cars.
instead of cars, it'd be Craigslist
Craigslist.
DB. I think is what we call it.
No, the database is Craigslist. The image was called Craigslist DB.
Gotcha. Okay.
All right. So this will work.
Yep. And we could do a /D
And that's going to tell me what?
if you
DT.
have any tables created.
Okay. Awesome. This right here ended up not working, right? But this should work, right?
Mm-hmm. It should work.
All right, let's try that again. I think if
Semicolon.
ah,
What happened?
Does it have to be underscore? I mean,
what
not
has to be
underscore,
underscored?
sorry. No, not create table.
What is my PS Postgres SQL command here? Why don't I just create the table manually? this command right here. What's wrong with it? I should be able to create this command, right?
Oh. Yeah, you should just be able to run it.
All right. Yeah, absolutely. So let's create the table. I want to create this exact table. It didn't run when I ran it from the script, right? So there's something wrong with it.
Right now it's pointing to the U, like if it's capitalized, you can't use capitalized U. Is that, does that have to be lowercase?
Uh,
App
uh,
user.
let's call it app user. What happened?
It created
So
it.
it's, it
Is
doesn't like
user
the
a reserved
user.
field?
It is in PostgreSQL, and I had forgotten. That was the issue, right?
Thanks,
So
Andrew.
this was failing, right? So if we call it app user and we do this, all right, so now we figured that out, right? You can't use user here. Someone research it, posted in the chat. I'm not quite sure why. I don't remember.
Keyword or something, maybe?
It must be. It's
Yeah.
it's not a keyword. They call them reserved words. It's probably some kind of reserved word within the PostgreSQL querying language. All right, so this should actually work then, right?
Yeah, if you renamed it, it should work now.
You
Okay.
gotta rename the insert into app user.
Uh,
Line 18.
Yeah, 18. You got to rename that too, right?
18. Yep. Let's do app user. All right. Let's redo everything.
You have to put it on a different port, I think, because it's gonna, right?
You just gotta call it .runner. You could either delete the other container that we built,
Yep.
or just call it Walker.
Docker runner 1. How about that? Yeah.
Sounds good. All right, from this point, it looks like you do Docker exec. So Docker
No,
space
no. What
exec.
happened? What happened there?
Still not there.
Still not there.
Runner is there, but the new one we were runner
Oh,
one is
the
not.
Walker. Okay, okay, gotcha. On the cars database,
On the what?
if we look at the cars database, that
Yep.
table, and you look where it's on line 18, it doesn't have, with the cars database, it doesn't have the first name and email in parentheses. It just set as insert into the table and then value.
Insert into app user values.
Yeah.
Like that?
Yeah, that's the
Correct.
way the cars one was.
Okay.
And I'm just going off of the cars one, yeah.
Yeah.
That's all I have.
Let's keep trying it. That was it,
Yay.
right?
Woohoo.
All
Got
right.
it.
Now I want to go into, where do I want to go into?
Runner one, the first one.
Runner 1. All right, I'm inside of runner 1. Here, it's the command. Nope, messed that up. Sorry, guys. Here. This is where I want to go into, right?
Without cars, it'd be crazy.
Craigslist. Now I'm going to hop on the database terminal inside of runner 1 that has James Blood on it. Yes? How do I verify that this is the right table, or that the table has the right contents? I can simply run what kind of query here?
Isn't it?
Select all.
Yeah. do that.
From?
Yeah.
From where?
App
App
user.
user.
Okay.
There's only one table, yes. All right, select star from app user. It should only be one. There we go. Was that just the right kind of painful? And you can just duplicate this. I'll post it in the Slack channel, right? But this is how I want you to start. I want you to start literally just with one. And we literally just gave them a first name and an email. Now build from this here. Yes?
So I have a question about how you fixed that though.
Yeah.
Because you removed basically the default values before values to tell what was going into it.
Uh-huh.
The reason I ask is in the school one, I had the same exact issue what was going on here. I can't get it to run when I created the Docker file, but the seed file that was given to us in that assignment had all those fields before values. And so is that the reason, that's the whole reason it fails, or is there ever a reason you would use those?
Sorry, say your question again. I don't understand.
So the school assignment that you gave us before this,
Uh-huh.
and then you said once you finish it, try to Dockerize it. So I was able to build the Docker image, but I was running into the same problem when I tried to run it. But the file that they gave us actually showed it with it being showing like insert into students, then it shows ID, first name in parentheses, everything like that, and then values, and then all those values in there. But you just deleted that to make the Docker file run.
Okay. So I'm going to give you the really simple explanation, right? If you're providing values for all the columns, you can do it this way. If you're providing values for just some of the columns, right, you need to tell it which columns, and they're going to be in order. So if you have something like insert into app user, right, and you were only going to give first name, well, let's use first name, I can't spell, last name, right? But that specific table had 10 columns and you're only providing 2, right? Then you'd give them those 2. Whatever. If you do it this way, it assumes, hey, all the columns, right? You're going to pass in everything that's required. Here it tells you, hey, there's more columns than this, but just do these 2. Because remember, not all of these are what? Required, right?
Yes.
So that's how you know. That's a little confusing, right? Just look at your schema, right? That's going to tell you what you need. Sometimes you'll have this and you'll have not null, right? These are required, but sometimes you can have something like the example we gave earlier, middle name, text, not null, which is not required. Did I answer your question, Nicholas?
Kind of. Just I'll play with it and see if I can get it to work based on that information. So is it if you're giving all the information, all of the values in there, and you tell it what values are going in there, is that where it breaks? And you would remove it if
no, that's when it works. If you're updating just certain value or you're giving it just certain values when it has more, right? You need to dictate which values are going in. It's really just a syntax question, right? Your syntax in this file, if you're going to execute it, all of it needs to be right. Notice how I messed up back. I forget that. Anybody Google why that is? Why you can't use user as a table? You can't use
put in,
huh?
in the message. The next you put in the message in the chat, I think. And telling you to
Okay. I'll look at it. But yeah, ultimately it's just a syntax issue. All this needs to be right. If not, it's not gonna launch the Docker container, right? If the information that you're seeding it is incorrect. Because when the Docker container runs, what's happening line by line?
Creates it, connects it, then creates
Yeah.
the tables.
All right. So conceptually, guys, think about it this way. This is your init SQL file. When the Docker container starts, it's trying to start. It's starting. It runs this line. It runs this line. If this line has a typo in it, it breaks, shuts down the container. It exits the build. So all this has to be right. If anything is out of place, you saw like I had a comma here, that wouldn't even allow it to work. The process that we took just now of like commenting things out and just starting it from the beginning, remember when we just commented all this out? That's the process I would take. Right? That's the reason why I gave you such little data. Notice how we just did initially just a first name and an email. That's the reason. It's easier to debug these little 10 lines than it is, 1,000 lines of data. Make sense? Do it this way. Trust me. This is going to help you a lot more. Questions about continuing this assignment?
Is it going to get easier?
Yeah, it does. It does.
I thought we were just supposed to design the schema or database for it. I didn't think we had to actually make one. So
make it. What's the point of designing it? Nothing.
I don't know. Just to learn how to do it.
Absolutely nothing. Design it as you're writing it. If you want to do a little art thing, knock yourself out. Right?
Yeah.
Really, but at the end of the day, I want a database with all the tables and for them to work.
Okay. That's
Right?
the direction. I'm just was wondering why the direction said the other thing, but whatever.
Guillermo, which one do you use? The second one or the first one on the number 4, inserting the data? You did the last one, right?
This is the right one. This I was just giving an example. There's nothing.
Cool.
I was just showing you when you have to identify which columns you're actually passing and arguments for. All right. I gave you this really small example. This is how everyone should start, though. I can post in the Slack channel. What would be the next step, though, before we go on break? If we got this to work, so our container works now, right? And it has this user. What would be my next step here?
We don't on the cars database. It shows to run the script SQL, but we don't have a script SQL yet. So I think the script SQL on the cars database was I don't know how to know exactly. Just had one table line. So that car, so it was just building it, not really building the tables, but queries. It looks like. So once you have your tables built the way you want them,
Okay,
now you can,
stop right there. You're rambling. I am here. What is the next step? Because this is where I'm going to cut you loose. What's the next step here? That's the only thing that I asked.
Build more tables?
Yes. That is the next one. How many attributes are these next tables going to have?
Few as possible.
As few as possible. And you're going to build all the tables with as few attributes as possible until you have what?
Fully working database.
A fully working database. that is sound and it works. After that, you're going to do what?
Dockerize it.
It's already Dockerized.
Add more attributes as needed.
Add more attributes as needed, yes. Add the primary keys, add the references, add the relationships to other tables. Do this first. So my next table, right? If I'm doing Craigslist, I have app user, my very next table, right? Create. Am I stupid? I can't spell create. No, I can't. Create table. What's going to be my very next table?
Maybe posts.
Yeah. Posts. And I'm just going to have, what do I want?
Maybe a title, description, and timestamp.
Yeah. Title. Can't spell title. Description. Don't use timestamp. Timestamps are actually kind of complicated. Don't mess with timestamp for right now. Description for right now. This is what I would build next. Something like this, or just post. Right? I would build this, run through this, right? And after you get all of this working, you're going to need what? You can build other tables, or you could do what to these two tables?
Join them?
Yeah, you're going to have to join them somehow, right? So think of what kind of serial primary key, how they're going to connect. Because an app user can have many what?
Posts.
Can have many posts, right? And after I figure out that connection, then I move on to the next table, right? If this could have just a title and even the connection to app user and not even no description, cool. Something like this, and then build the next table, right? I would do that. That'd be the easiest way to do it. It's going to be much easier to debug it and just include, you could script it and add users as you go, or you can even insert it manually, whatever's easiest for you. But build your tables with as few attributes as possible initially. It's going to be much easier. Questions about the assignment? Give me 1 second. Let me search this. Yeah, the word user, capital U-S-E-R, is a reserved word in PostgreSQL. That's why we were erroring out, and I had forgotten. And that actually explains why the README had app user instead of user. I think I've made that mistake many times. That's something that I've forgotten. Remember when you see the all the create table in capital letters, right? That's just a convention. They can all actually be lowercase. I don't know if anyone's noticed that, right? The capitalization there actually doesn't do anything. Did everyone know that?
Yeah, I accidentally didn't capitalize and it worked. So
Yeah. So that's just, I don't know how it's rated. It's just a convention. But again, in programming, that's why it just takes so much experience and so much practice and hands-on learning, because sometimes the way that the syntax is written doesn't matter. And sometimes it really does. Right? That user table name is a great example. I had forgotten about that. That's just someone that doesn't really use PL SQL very often. Right. But when someone tells me, oh, hey, that's a reserved port, oh, okay, that makes perfect sense. It was hitting that line in the init script and it was breaking. All right, guys, it's 11:08. Definitely take like 40 minutes, grab a lunch or something, grab some breakfast. I will post your programming buddy groups in the Slack channel along with this code that I just wrote. Sound good? All right, dude. Get somebody